Hi, this is Anil Bharti, and we are here at TFIR Videocast. And today we have with us Jason Vanderscape, your Chief Operating Officer at SoftIron. And today we are going to talk about HPC and how this space is kind of growing and evolving beyond the typical understanding of HPC. So before we get into that, first of all, welcome to the show.
Thanks. It's great to be back.
How are things at your end at SoftIron?
Yeah, SoftIron, we're continuing to grow. We're still a small company. We're growing now. We're probably 45 people. So, we're shipping products. We've got a number of trials underway at a couple of big universities, the national labs, and yeah, it's all going really, really well. It's exciting times.
Excellent. Now let's talk about HPC, high performance computing. Talk about its kind of importance and role and how it's changing in the data centers.
Yeah, absolutely. So traditionally, when we think about high performance computing, we think about supercomputers, large, national labs, systems built by Cray, which is obviously now, part of HP. But really what we've seen with the emergence of the cloud is that if you just have a lot of computers, you can orchestrate them in a way that they start to act like sort of a mini supercomputer. So the whole idea of high performance computing is really transitioning out of the supercomputer realm and into a lot of research facilities and even into a lot more corporations than we've previously seen. That coupled with an explosion of data that's being generated in AI, ML, autonomous vehicles, the amount of data that's being generated by an autonomous vehicle on a per day basis is just unlike anything that we've seen in data for decades. And so the problem with having a lot of data, or the good side of having a lot of data, is you have to be able to process that. And so in order to be able to create these amazing inference engines that are able to look at autonomous vehicle footage or LiDAR information and actually process that to be able to build algorithms or just analysis, we need a massive amount of compute power. And the cloud's brought that to the majority of users in a really interesting way that allows them to act as if they have their own supercomputer, but really it's living in a data center far, far away from where they physically are.
And you gave some examples, but if you look at HPC, traditionally it's seen, a lot of research is using HPC, cancer research and nuclear plants, they're using HPC. So what are the typical verticals which are, consuming HPC, or where HPC makes more sense?
Yeah, so I mean, the most traditional places that we're seeing, high performance compute is national research labs where they might be doing enormous weather models. Obviously, nuclear research, we've seen that for a long time. People like CERN are doing a massive amount of computing in the experiments that they end up running. But we're also starting to see this real thirst in genomics and in an uptake in how we're being used, how we're using computing in genomics. We're trying to not only sequence primary DNA, but now we're starting to look at all of the other options of comparative DNA. So in a cancer, cancer is a great example of this, of sequencing not only the patient's DNA, but also any mutations that might exist in the cancer itself, and wanting to be able to do this very, very quickly. And also to be able to provide it to a massive number of people. Today you and I can go and get a full sequence of our genome done, but it's still tens of thousands of dollars, which isn't accessible. One of the prospects that HPC has, especially in that realm, and this idea of personalized medicine, is that the entire population would be able to go and benefit from having their genome sequenced, but that requires a huge amount of compute, and that's really what we're seeing. Is actually now possible with sort of decentralized compute. So it's not a large supercomputer; it's just lots and lots and lots of individual computers, and that's even changed the way that supercomputers themselves are being built. It's taking more commercially off the shelf processors or CPUs, SoCs, and using novel ways to interconnect those and place that in a single compute environment.
Yeah, I'll come back to the evolution of computers. So I'll just go back to the use cases as well. Some of these use cases, when we talk about genomics or health, they are like traditional use cases of HPC. But when we look at, you mentioned some like machine learning, AI, a lot of emerging technologies are coming in, and the data is being. So what are the new use cases that you're seeing which may create new markets?
Yeah, I think great new markets as far as HPC and really fit into that machine learning, artificial intelligence. So we look at autonomous vehicles. That's a great starting point of, even if we're not talking about fully autonomous vehicles, just vehicles that are partially autonomous and now capturing huge amounts of data and wanting to be able to process that information. We look at aerial vehicles or, drones or something like that. It's a similar process. We've now got to this huge breakthrough in one technology that was limiting our ability to do these things, which is small brushless motors and lithium batteries. Those two things have got to a state of maturity that now we can have, lots of flying vehicles, lots of electric cars. And as soon as we do that, and we've historically always done this as a society, is we start to attach, more sensors to those vehicles and start capturing much more data. Having lots of data is terrific, but you really need to be able to do something with that data. And that's really where we're seeing these emerging markets of HPC. We're seeing, aerial mapping with drones, the idea of drone delivery. Drones are now going to have to be self-aware of each other, and there's not going to be air traffic controllers telling drones where to go. They're going to have to do that themselves. And all of these things have a data cost. Telling vehicles where they can drive and where they can't drive, where they can fly and where they can't. It's huge amounts of data, and that's happening sort of all over the place. I mean, we also see it in places like energy exploration, geophysics. We've always thrown off huge amounts of data, but now we're getting 3D scanning equipment that's able to take even higher resolution images of the seabed or what's beneath the seabed. And so again, we get to larger files, which we now need more compute to be able to process and to infer information out of. And that's really where this sort of second wave of HPC is really happening.
Yeah, so let's talk about the unique challenges in terms of storage. The amount of data, not only VR, 3D, or machine learning, or genomics, or nuclear plants they are creating, it's massive. And since SoftIron is basically, you're in the storage space with Ceph. So how unique is data challenge in the SPC environment versus traditional data centers or supercomputing environment?
Yeah, so, traditionally in a supercomputing environment or traditional HPC, we've seen a massive thirst for large parallel file systems. Things like Lustre, Gluster, GPFS. And those file systems are absolutely focused on speed. They want to capture all of the data as quickly as it's being thrown sort of out of the fire hose of the supercomputer. And that's worked really well. Historically, it continues to work really, really well. Those file systems are, likely to always be tier 1 HPC storage. And that's because what they can do very, very well is handle a large amount of data very, very quickly. The complexity comes that now we don't have supercomputers that are built in single facilities as much when we start talking about these emerging centers. Is now we have more consumers of that data, whether it's researchers who may be completely scattered across the globe, whether it may be sort of teams that are split even in very close geographies but aren't physically attached to a network. Maybe it's that you want to be able to transport that data and keep some of it in a cloud environment. Or, what we really believe is the emerging technology here is this notion of hybrid cloud, which is it's not all in the cloud and it's not all on premise. There's a mix there. And the cloud is great at being able to transport and kind of store archival information or make it accessible with access controls. But it can be expensive if you're pulling data in and out. And so having on-premise storage then allows you to do this element of the high in and out, read requests, write requests, without paying a bandwidth overhead or an actual cost overhead of running in the cloud. And so, as we start to look at these emerging markets where we're talking about autonomous vehicles or machine learning, there's not an access to a fixed physical supercomputer or fixed physical large compute center. And a great example of this that we've seen is in that energy exploration market with geophysics is the companies that are going and doing the exploration are not the consumers of the information. The end consumers of the information are the oil companies or the companies who want to monetize whatever resource is there. The companies that are doing the exploration or the geophys surveys are going and doing that basically on their own cost, and then they're going off to sell that to whoever they want to be able to do that. So we see a couple of tiers of storage and a couple of different types of storage in that example, which is, we're actually capturing the data on board whatever type of vehicle or vessel is doing the survey. So that's some form of on-premise server of on-premise storage, just because we don't have the uplinks if we're in the middle of the ocean. Then that gets transferred to land into a very large facility where it can be processed by the geophysicists. They can determine what the energy, exploration possibility is. And then they need to make that available to a series of customers. And that's where we start to see the cloud coming into play, because it's a way of being able to not have to provide physical access into your data center, which of course, has security implications. You can move it up into a cloud environment, whether it's an S3 bucket or something as simple as that. And then from the purchaser's perspective or the customer of that data, they may be massively spread out all across the globe. And that's where, getting something that looks like object storage, be it in the cloud, be it something like Ceph on an on-premise solution like we provide, starts to mean that you get the best of both worlds. Of if I'm an oil company, I can keep that data that I've just purchased for a very large amount of money on my physical premise, and then I can make all or parts of it available to bits of my team that are spread out, or, kind of wherever that sits. And that's something that we haven't traditionally been able to do. And even the cloud over the last, handful of years, the challenge that we've had is it's not been as larger data sets. Now we're talking about just enormous data sets that need to be shared.
You mentioned Ceph. I mean, of course, these days everything is software defined, and Ceph is playing a big role there. But I want to hear from your perspective, how would you define Ceph in this HPC environment? I mean, it's one of the most popular open source projects out there, and why it's so too critical to the HPC environment?
Yeah, so at SoftIron we bet the company on Ceph a couple of years ago when we started building storage environments, and we really believe that Ceph will and it is already becoming the Linux of storage. And there's a number of reasons why that's true. Probably the biggest selling point with Ceph in this instance and around HPC is, Ceph is not just object, it's not just block, it's not just file. It can do all three, and it can do all three concurrently. So what that means is I can have a native connection into an S3 gateway. I can also at the same time mount a file system so my researchers or my consumers can be accessing that data, and I can pipeline directly into my very, very large parallel file system, Lustre, Gluster, GPFS, to be able to take that initial data that's being stored as part of the experiment or the large, fire hose of data that's coming. And then I can put it into a number of environments that coexist, that support all of my needs for that, whether it's a simple file share for some researchers who are accessing it on a laptop or a desktop, who are scientists, not IT professionals, right? So they just need something that's very simple that'll mount to their drive, their laptop as a drive. At the same time, we may need to be transferring it in and out. And Ceph does that incredibly well. It's an open source project. There's a lot of people working on it. And there's a huge number of people in the HPC sort of scientific compute space working on it. CERN is such a great example of that. They have, in excess of 40 petabytes of Ceph data that they're working with. And they run, loads of their experiments, and we see it all over the place. I mean, we know that it's happening inside national labs. We know that it's happening inside universities, and interestingly, there's a birds of a feather talk at the upcoming supercomputing conference, which is specifically about Ceph, where these sort of luminaries of the supercomputing industry talk about how they're using Ceph, and it's really got a firm place in that market.
Right. I mean, if you look at Ceph, as you rightly said, it's an open source project. Anybody can take it. But typically, open source projects are like driven by community, which is they solve the problem of a wider community. But when you look at your customers or users, they have a specific problem they want to solve, or you want to offer a lot of value on top of Ceph, just the way other companies like Red Hat or SUSE offer a lot of value on top of Linux. So, so how do you take Ceph and add value to it? So can you talk about what kind of product portfolio you have around Ceph, which help customers in using Ceph in a much better way?
Yeah, absolutely. So, we set out to build a fully supported appliance for Ceph. We call it Hyperdrive, and it comes in, a number of flavors based on the workload that it would see. So everything from, SATA spinning disks at the low end to much higher end SSD-based solutions, across the gamut of networking as well. So, from 10 gig all the way up to 100. And really the reason that we did that was there was a lot of gains that we saw that were able to come out of Ceph by not messing with the software, but actually providing a very robust hardware environment on which Ceph could run. And so we have lots of little examples like that where we, for example, don't have any internal wires inside the appliance. Everything is connected with, hard connectors, copper traces on PCBs via a very, very high-speed backplane. And that doesn't sound like it would make a huge impact until you start to compare that with what happens when you move a SATA cable inside a regular server while you're doing a large read or write event. And you end up with a massive amount of packet loss in that process. Now, there's things within the SATA protocol or the other protocols that help to buffer that and send it back. But all of these things slowly degrade the overall performance. And so really that was one part of it, was how much more performance could we get out of Ceph? The second part of it was, no one else is really providing a single vendor solution for Ceph. So being able to call SoftIron up and say, I've got a problem I want to solve. I think Ceph's the right answer, but I really only want to deal with one vendor. I don't want to have to deal with a hardware vendor and a separate software vendor. And then when something goes wrong or there's a complication, who's going to solve that problem for me? So that was the second thing that we took on. And then the third real function was, Ceph can be incredibly complicated to use. It's built in such a way that there's so many things that can be done that means that it can be very, very complicated to set up and run properly. So we put a very large focus on making Ceph user-friendly. We've built our own user interface to help set up shares for users who are not familiar with Ceph, while still providing all of the functionality of Ceph at the command line. And we don't touch the internals of Ceph at all, in any divisive manner. Everything we do just looks like regular Ceph. It's not changed by SoftIron in any way, with the exception of when we do come across opportunities to optimize, we do commit those upstream, and we are a contributor into that. And we're a very proud member of the Ceph Foundation as one of the founding members, alongside people like Red Hat and SUSE and Intel. And we, along with those organizations, really believe in the future of Ceph, and think particularly in HPC, it's a really great fit as a tier 2 storage opportunity.
So, I mean, Ceph is basically a kind of general purpose storage solution, software defined. But uh, so, is it by define? Is it by design kind of suitable for HPC environment, or you with either hyperdrive or storage manager, you just kind of optimize it to better suit in the HPC storage, or Ceph is just an awesome solution which just works there?
I mean, Ceph, I think Ceph is just an awesome solution and it works there. We've seen Ceph work, historically very well in an OpenStack environment with large amounts of data sets. A lot of HPC customers are also running OpenStack environments. There's a lot of crossover there. I think what we've been able to show with just the pure performance gains that we're able to get out of Ceph as it's built on top of our platform, where we're talking about wire speed, that's one of our claims of, we will transmit data at wire speed through that appliance because we have a novel architecture where, we are so focused on getting data from the network to the drive and back from the drive to the network that we have, radically different approach to the way that we've built some of that hardware. And those performance gains have meant that it makes Ceph a real contender as a tier 2 storage option, beneath something like Lustre or in a true HPC environment. So it's a little bit of both. I would say that Ceph is a natural contender. We've seen lots of people that are running it. We just like to think that we've made Ceph a little bit better and a little bit easier to use. That for those people who maybe tried Ceph 5 or 6 years ago and struggled. It's time to have a look again, and the project's moved on a long way, and I think it's an exciting time for Ceph in general.
So tell us a bit about because you're going to be at SC19. Tell us a bit about the event itself, and then what is SoftIron doing there?
SC19 is the premier scientific computing HPC supercomputing show in North America. It's massively well attended by all of the large universities, research institutes, national labs, both domestically and internationally. And it's a real focus for us on our event calendar of, SC19 is one of the first things that we signed up to this year. So we'll have a large group out there. We have some customers who will be alongside us talking about their experiences with not only Ceph, but also, working with SoftIron. And then, a highlight for us is that there's actually a dedicated Ceph Birds of a Feather, which is held on the Monday of SC19. This year, the show's out in Denver. So we're really looking forward to that. Our CEO will be making a small presentation. We'll be talking about actually how we've deployed Ceph into both one of the large national labs in the US and also a university up in Minnesota. So we'll be there talking about that, and we have a large booth presence. We'll have some hardware on show. And, everyone loves coming and having a look at some hardware when they come to these events. And we're really looking forward to that week in Denver.
And you'll also be at KubeCon in San Diego. Yeah, tell us a bit about what are you going to show at KubeCon?
Yeah, so Ceph is a great fit for Kubernetes. As Kubernetes has started to evolve to become more than just a thing that app developers were kicking around. There's this concept of persistent storage in Kubernetes, and from the outset, Ceph is cloud native in the way that it's built, in the way that it interacts. And so this year at KubeCon in San Diego, we're going to have a Ceph Day, which is going to be on the Monday prior to KubeCon kicking off, as sort of all the day zero events are running around. And those Ceph days are great. They get the community together. Sagewell will be, no doubt giving a state of the union of the update as we move towards the next release of Ceph, which will be Octopus. And then, the next 4 days at KubeCon there in San Diego with kind of lots of opportunities. So we'll be at both. Again, we'll have teams of people there, hardware on display, and we had such a great time at KubeCon in Barcelona. was a great event for us, and really looking forward to something on home soil.
So Jason, thanks once again for taking your time and talking to us about not only HPC, but your presence at HC19 and KubeCon. And I actually look forward to seeing you at KubeCon soon.
Yeah, looking forward to seeing you in San Diego. Thanks for having me on the show.